If you've come here looking for a lesson on matrix multiplication, well, you found the right place. I'm going to begin with a simple matrix. Now, this matrix has one row, and the matrix on the right, has one column. So the way you multiply a matrix is first you have to make sure that the dimensions are compatible. This one is one row by two columns. Columns go vertically. And this one, the one on the right, is two rows by one column. Now what we're looking for are that these inside dimensions are the same, and they are. The new dimensions of your matrix are going to be 1 and 1. So you're going to end up with a single number. Now the way we multiply a matrix is you take a row and you multiply it by a column. The first element in each row and column get multiplied, and the corresponding elements also get multiplied, and you add them together. So what we have is 3 times 1 plus 2 times 4, and it's going to be in the brackets to represent that this is indeed a matrix. Now we will simplify these numbers in our bracket and have 3 plus 8, which is 11. So let's try something with a little bit more to it than a final answer of a 1 by 1 matrix. Now these two matrices are both 2 by 2. And since the numbers in the middle are equal, we can multiply them, but we will have a matrix as a result that will be 2 by 2. So we're going to start exactly the same way we did before. We're going to take a row, we're going to take the first row and multiply it by the first column, identically to what we did in the first problem. So we'll take our 3, multiply it to 2, and 5 and multiply it to 4, and then we're going to add those two. So you'll have 3 times 2 is 6, plus 20. So that gives us the first element in our matrix. So we're going to go back to the first row, because we are dealing with the first row here. So we've got to find the first element of this column. So we're going to move over to this column. So the top row, second column. So we will have 3 times negative 1, so negative 3, and then 5 times 0, so plus 0. Okay, we're done with the first row. So we're going to move down to the second row, and we're going to complete the same exact process. So we need second row, first column, which is that spot. So negative 4, and we're going to multiply the 4s, 16. And for the last spot, for this last column, last row, we're going to use the last column in the last row. And negative 2 times negative 1 is 2, and 4 times 0 is 0, so I'm not going to write that down. So we're going to simplify this, and we have 26, negative 3, 12, and 2. And that is our matrix after multiplying the two matrices. Alright, so I saved the best for last. This one is 3 rows by 2 columns. This one is 2 rows by 3 columns. So we're going to knock these off. What we're looking for is the matrix that will be of dimension 3 by 3. So I'm going to make this pretty large. Now what we're going to be doing, remember, the column and the row that you are multiplying corresponds to its position in the matrix. So I'll have a first row, first column. So we're going to fill in this spot right here. So we have 2 times 2 is 4, 3 times 5 is 15. So our first element will be 19. Now we want to fill in first row, second column. So we're going to use first row, second column. So we have 2 plus 9, and that's 11. Now we're filling in first row, third column. So we use the first row and the third column. So negative 2 plus 6 is positive 4. Just fix that. Okay, first row is finished. So we're finished with 2, 3. We're going to move down to negative 4, 2. So we're looking to fill this column, this row in. We're going to use this row and all 3 columns. So negative 4, 2 and 2, 5 is what we're dealing with right now. So negative 8 plus 10 is 2. I'm going to move over. Second row, second column. Negative 4 plus 6, 2. And then we have second row, third column. And that will be 4 plus 4, which is 8. Okay, third row, first column goes here. So that's 0 minus 5. Okay, third row, second column goes here. 0 minus 3. And then the last one is negative 2. And that is how you multiply matrices of varying dimensions. Now, the most important thing, these inside numbers, these inside dimensions have to be equal, or you cannot multiply the matrices. So, happy multiplying.